Hi everyone. Welcome to Navigating Migrations, a comprehensive guide to Microsoft Fabric. My name is Aarthi Arumugam and I'll be your instructor today. I'm excited to guide you through this important and comprehensive course that will help you navigate the complexities of migrating to Microsoft Fabric. Fabric is an all-in-one data and analytics platform that's rapidly becoming the go-to solution for businesses looking to modernize their data infrastructure. As organizations evolve, managing data analytics, and machine learning in a unified platform becomes increasingly important. In today's session, we'll dive deep into how to migrate from Azure Synapse Analytics to Microsoft Fabric, while also learning the ins and outs of using Fabric to manage data pipelines, perform real time analytics, and drive business intelligence insights. Now, let's explore who this course is designed for, and then we'll go over the key objectives we will be covering today. Before we dive into the technical details, it's important to understand who this course is for. This course is tailored for professionals who are involved in data migration, data management, and analytics. Whether you're a data engineer, data scientist, IT administrator, or cloud professional, this course will help you get up to speed with Microsoft Fabric and its powerful capabilities. Let's break it down. If you're a data architect or a data engineer, you're responsible for building and optimizing data systems that can handle vast amounts of data while maintaining efficiency and scalability. This course is for you because we'll show you how to migrate your data workflows from Azure Synapse to Microsoft Fabric, focusing on data pipelines, data lakes, and data transformation processes. We'll also explore key aspects like SQL pool migration and advanced data integration. As a data analyst or data scientist, you work with data to uncover insights, create reports, and contribute to business decisions. Microsoft Fabric integrates well with Power BI, which allows for seamless reporting and visualization. If you've been using Azure Synapse or similar tools for your analytics, this course will help you understand how to make the transition and how to leverage Fabric's enhanced capabilities for data exploration and advanced analytics. We'll walk through the key tools like notebooks for data exploration and pipelines for automating workflows. If you're part of the IT infrastructure team or a cloud professional managing data systems, this course is perfect for you as well. Microsoft Fabric requires a well organized and secure environment. You'll need to understand how to set up Microsoft Fabric in your environment, manage permissions, and ensure that your team has the right access to data. Additionally, we'll be discussing how to move SQL server-based environments and Azure SQL to the Fabric platform, ensuring the smooth operation of the new system. Even if you're not directly involved in hands-on data management, this course can help you understand the strategic side of using Microsoft Fabric. We'll show you how it can improve data governance, reduce time to insight, and drive better business intelligence. As a project manager or business decision maker, understanding the architecture of Microsoft Fabric and how it supports modern data needs can help you lead the migration projects with confidence. In short, this course is for anyone who needs to move, manage, analyze, or extract insights from data in a modern, scalable environment. The migration to Microsoft Fabric will streamline your processes and empower you to deliver better results. Now that we understand who this course is for, let's talk about the objectives and what you will achieve by the end of this course. Our aim is to provide you with the knowledge and practical skills necessary to successfully migrate and utilize Microsoft Fabric in your data architecture. The first objective is to walk you through the entire migration journey from Azure Synapse Analytics to Microsoft Fabric. Many organizations are still using Synapse, but Microsoft Fabric offers a more integrated, scalable solution for data management, analytics, and machine learning. We'll discuss the key differences between the two, how to plan the migration, and best practices to ensure that the transition is smooth. For example, you learn how to migrate data pipelines, which is critical when moving complex workflows between platforms. We'll provide a hands-on example of how to migrate Synapse pipelines to Data Factory within Microsoft Fabric, and why this is a more efficient solution for future-proofing your data infrastructure. The second objective focuses on migrating SQL pools from Azure Synapse to Microsoft Fabric. Many of you may already be using Azure SQL pools in Synapse, and the goal here is to show you how to seamlessly move those workloads into Microsoft Fabric. We'll explore different SQL models in Fabric and how they compare to Synapse SQL pools. We'll also provide examples of how to maintain performance and scalability during this migration and take advantage of the advanced SQL capabilities in Fabric, including better query performance and reduced maintenance overhead. Data Factory plays a central role in data integration within Microsoft Fabric. This third objective will show you how to migrate your existing Azure Data Factory pipelines to Data Factory in Microsoft Fabric. We'll cover the various tools and features in Fabric's Data Factory, including Power Query integration for more powerful data transformation capabilities. You'll also see how Data Factory helps integrate external data sources into your workflows, ensuring your data pipelines remain robust and maintainable in the cloud. We'll highlight key integration points with services like Power BI, making your entire data processing and reporting workflow more efficient. For those who are already familiar with Azure Synapse, we'll guide you through the process of transitioning your workloads to Microsoft Fabric. While Fabric offers many of the same capabilities, we'll explore the new features that make it a more unified platform. This module will help you understand how to adapt your existing systems, making use of Power BI, data lake, and machine learning to handle data storage, processing, and real time analytics. We'll discuss how to seamlessly manage this transition and ensure minimal disruption to ongoing business operations. One of the most exciting features of Microsoft Fabric is its focus on lakehouses, a hybrid between data lakes and data warehouses. The lakehouse model allows businesses to store raw data and then easily transform it for analysis, offering both scalability and flexibility. We'll cover how to create and manage lakehouses within Fabric and how you can use them for advanced analytics. You'll learn the best practices for loading, transforming, and querying data within a lakehouse environment and how it can integrate with other Fabric services like notebooks and pipelines for seamless data flow. Finally, we'll explore the SQL migration process, focusing on how to transition from legacy SQL based systems to Microsoft Fabric. This is particularly important for teams that have been using SQL Server or Azure SQL but want to move to a more modern cloud native solution. This objective will provide practical guidance on how to optimize performance, maintain data security, and ensure consistency during the migration process. We'll also discuss how to make use of Fabric's real time analytics and machine learning capabilities to take your SQL workloads to the next level. Before we proceed, let me ask you, how many of you are already working with Azure Synapse or similar tools? You might find that some of the concepts here feel familiar, but we'll also introduce new features and best practices to ensure you're fully equipped to handle the migration to Microsoft Fabric. Welcome to the heart of this course, Microsoft Fabric. Before we dive into the detailed tools and techniques within Fabric, let's take a step back and discuss the overall platform. We need to understand why Microsoft Fabric is such a powerful solution for organizations seeking to modernize their data architecture and workflows. Fabric is a unified analytics platform that integrates multiple functionalities such as data storage, transformation, machine learning, and business intelligence into a single cohesive solution. It's designed to help organizations streamline their data processes, ensuring that data is available, secure, and ready for analysis in real time. Unlike traditional systems where you might have to rely on multiple isolated services such as Azure Synapse, Azure SQL Database, Power BI, and more, Microsoft Fabric brings everything together in one place. This integration allows for greater collaboration, simplified management, and improved scalability. Think of Microsoft Fabric as a platform that eliminates silos within data management, enabling organizations to handle complex data workflows with ease. One of the core strengths of Microsoft Fabric is its ability to support end to end analytics. That means Fabric isn't just about collecting and storing data, it helps you manage the entire lifecycle of your data from ingestion and transformation to storage, analysis, and visualization. Let's take a closer look at the learning objectives for this course. These objectives are designed to guide you through the key concepts and skills you'll gain as we progress. By the end of this session, you should be able to describe end-to-end analytics in Microsoft Fabric. Let's talk about the first objective. End-to-end analytics refers to the complete process of managing data, transforming it, performing analysis, and deriving actionable insights. With Microsoft Fabric, you can manage this entire workflow from a single platform. You'll understand the different data teams and roles that use Fabric. The second objective is about understanding who uses Fabric and the different roles that interact with the platform. Microsoft Fabric is designed for data professionals who work at various levels of the data pipeline. This objective will give you a clear understanding of the roles within a data team and how they collaborate to manage, transform, and analyze data in Microsoft Fabric. A third objective is all about enabling and using Microsoft Fabric. This part of the course is crucial for those who will be responsible for setting up Fabric in their organization. This objective will guide you through the setting up and using of Microsoft Fabric, ensuring that by the end of this course, you'll be able to deploy it in your organization and start working on data projects right away. Let's dive into the core components that make this platform so powerful. Microsoft Fabric isn't just a one size fits all solution, it's a suite of interconnected tools and services designed to handle various aspects of data management, transformation, and analytics. To give you an overview, Microsoft Fabric is built around several key components that work together to enable end to end data workflows. These components provide the flexibility to handle large scale data workloads, perform real time analytics, integrate with machine learning models, and generate insights all from one unified platform. We have Data Factory, which is an essential tool for data integration and orchestration within Microsoft Fabric. Data Factory is responsible for moving and transforming data across systems, whether you're working with cloud data, on premises data, or external data sources. With Data Factory, you can automate ETL, extract, transform, load workflows, schedule data movements, and even create custom transformations to prepare your data for analysis or reporting. One of the key advantages of using Data Factory in Fabric is that it integrates seamlessly with the Fabric ecosystem. For example, you can move data from one lake into a lakehouse for further transformation and analysis, or you can integrate with tools like Power BI to visualize your transformed data. Imagine you need to pull in customer purchase data from an external API every day and clean it before loading it into a data warehouse for analysis. Data Factory can automate that process, saving you time and ensuring that your data is always fresh and ready to be analyzed. Data engineering within Microsoft Fabric leverages Apache Spark for data transformation at scale. It allows you to process large data sets and apply advanced transformations. Some key features include distributed data processing, advanced transformations, and integration with lakehouses. If you are working with log data, for example, from thousands of IoT devices, data engineering allows you to clean, enrich, and aggregate that data in parallel, making it ready for analysis in a fraction of the time it would take with traditional tools. The data warehouse in Microsoft Fabric provides high performance, scalable storage and processing capabilities for structured data. It's a critical component for organizations that rely on SQL based analytics for business intelligence. In Fabric, the data warehouse service allows you to store and query large volumes of structured data efficiently, which is ideal for business analytics and reporting tasks. It uses a columnar storage format to optimize query performance and ensure fast response times, even with massive datasets. Let's say you work for a financial services company and you need to query transaction data for analysis. By using Microsoft Fabric's data warehouse, you can quickly progress terabytes of transaction records, running SQL queries to generate reports on customer behavior, fraud detection, or daily cash flow. For instance, you could write a query to aggregate transaction data and generate a daily report on total sales across various regions. The scalability and performance of the data warehouse ensure that this query runs efficiently even if your data grows over time. Next, we have data science, which is designed for advanced analytics and machine learning. In Microsoft Fabric, data science enables you to build, train, and deploy machine learning models in a scalable, managed environment. This component leverages Azure Machine Learning to provide a robust platform for performing data science tasks such as data pre-processing, model training, model evaluation, and model deployment. Imagine you work for an e-commerce company and you want to build a recommendation engine to suggest products to customers. Using Microsoft Fabric's data science tools, you can collect and clean historical customer data from your lakehouse, build and train a recommendation model using machine learning algorithms like collaborative filtering, and deploy the model so that it's available in real time to serve personalized recommendations to users browsing your website. Moving on to real-time intelligence, this component allows organizations to analyze data as it is being generated. With streaming analytics, you can gain insights from live data feeds and act on that data immediately. This is particularly important for businesses that need to respond to rapidly changing conditions or make data decisions based on real-time data. Suppose you work for a telecommunications company that needs to monitor network traffic in real time. With real-time intelligence in Microsoft Fabric, you could continuously ingest data from network routers or devices, use streaming analytics to detect traffic spikes, network failures, or unusual patterns, and trigger real-time alerts and workflows to respond to these issues immediately. Finally, Power BI is Microsoft Fabric's business intelligence and data visualization tool. It is widely used for interactive reporting and dashboard creation. Power BI integrates deeply with Microsoft Fabric, allowing you to turn your raw data into insightful reports and dashboards. With Power BI, data analysts and business users can visualize data from lakehouses, data warehouses, and other Fabric components and share those insights across the organization. For example, if you are working with sales data, Power BI can pull in data from your data warehouse or lakehouse and create real time dashboards showing sales performance, inventory levels, and customer satisfaction scores. Business leaders can then use these insights to make quick decisions and adjust sales strategies on the fly. These powerful tools working together ensure that you can handle complex data workflows and generate insights that help your organization stay competitive and data driven. Now that we've explored the core components of Microsoft Fabric, let's talk about how these tools are used by data teams within your organization. A successful data platform relies on seamless collaboration between multiple teams, each bringing their expertise to different stages of the data lifecycle. In Microsoft Fabric, data professionals from a variety of roles can collaborate effectively, with each team using specific tools within Fabric to manage, process, and analyze data. This unified architecture makes it easier for teams to work together, ensuring that data flows smoothly from ingestion to transformation and finally to visualization and decision making. Let's discuss the key data roles within an organization, the tools they use in Microsoft Fabric, and how their work contributes to a successful data strategy. Data stewards. Data stewards are responsible for maintaining the integrity, quality, and security of the data used across the organization. They ensure that data is accurate, consistent, and trustworthy. Data stewards often work closely with the compliance and legal team to ensure data meets privacy and security regulations. Data governance and data quality are the key responsibilities for data stewards in Microsoft Fabric. For example, a data steward might set up data validation rules in Data Factory to ensure that incoming customer data is consistent and follows established naming conventions, preventing errors before they propagate through the data pipeline. Power BI users. Power BI users are typically business analysts or decision makers who use Power BI to create interactive dashboards and reports that visualize key business metrics. They often collaborate with data engineers and data scientists to pull in the necessary data for reporting, and they help translate complex data insights into actionable decisions for business leaders. Visualization, self service capabilities, and collaboration are some key responsibilities for Power BI users in Microsoft Fabric. An example is a Power BI user at a retail company could use Power BI to create a sales performance dashboard that visualizes sales data from the data warehouse, allowing managers to see top performing products in real time. Data engineers. Data engineers are responsible for building and maintaining the infrastructure that allows data to flow smoothly across different systems. They design and implement data pipelines, ensuring that data is cleaned, transformed, and loaded into the appropriate destination systems, like a lakehouse or data warehouse. They play a key role in setting up automated data workflows and optimizing them for scalability and performance. Some key responsibilities for data engineers in Microsoft Fabric is using Data Factory to design and automate ETL, extract, transform, and load processes. They work with tools like Data Flows Gen 2 and notebooks for complex transformations. Data engineers are responsible for ensuring that data is pulled from diverse sources like databases, APIs, and flat files and integrated into one lake or lake houses for easy access. They also optimize the performance of data transformations and queries using Spark in the data engineering component of Fabric. An example is a data engineer at a logistics company might set up a pipeline in Data Factory that pulls in data from various tracking systems, clean it, and load it in Lakehouse for analysis. The pipeline could automatically run every hour to ensure data is always up to date. Let's move on to discuss the role of data scientists. Data scientists are responsible for analyzing large volumes of data, finding patterns, and building machine learning models to predict outcomes or automate decisions. They often collaborate with data engineers to ensure that the data is in the right format and with Power BI users to ensure that their models' outputs are actionable for the business. Data scientists in Fabric use Azure machine learning and data engineering tools to build and deploy models. They can access data from lakehouses or one lake, perform data processing, and train models. After training models, data scientists deploy them for real time predictions or batch processing. They often collaborate with data engineers for data pre processing and with Power BI users to ensure insights through interactive dashboards. A data scientist in an e commerce company, for example, could use machine learning algorithms to build a recommendation engine for personalized product suggestions. The model could be deployed into production using Microsoft Fabric's ML tools, where it continuously learns from new customer data. IT administrators are responsible for the technical setup, configuration, and maintenance of the Microsoft Fabric platform. They handle everything from managing user access to ensuring the platform is running efficiently and securely. IT administrators enable Microsoft Fabric in the organization by configuring the platform settings, including workspaces and data access permissions. They ensure that sensitive data is protected, applying security policies, and managing user roles within the platform. They also monitor platform performance and troubleshoot issues related to data access, integrations, and infrastructure. An example is an IT administrator at a finance company might set up Fabric workspaces for different departments and manage access to sensitive financial data, ensuring that only authorized users can access specific reports or dashboards. One of the most powerful aspects of Microsoft Fabric is its ability to facilitate collaboration across these various teams. Here's how the process actually works. Data stewards ensure the data is clean, consistent, and secure. Data engineers move and transform the data into usable formats, creating pipelines for automated data workflows. Data scientists analyze the data and build models that provide insights, predictions, or automation. Power BI users take the output from data engineers and data scientists and create visualizations, reports, and dashboards that allow stakeholders to make decisions based on that data. IT administrators ensure that all teams have the proper access, security, and infrastructure to work efficiently. With Microsoft Fabric's unified platform, these teams can seamlessly collaborate to turn raw data into actionable insights. Fabric's integration between tools like Power BI, Data Factory, Azure Machine Learning, and Lakehouses makes it easier for data professionals to work together, share insights, and achieve better business results. Now that we've explored the key components and roles within Microsoft Fabric, it's time to focus on how to enable and use Microsoft Fabric within your organization. Enabling and setting up Microsoft Fabric requires careful planning and configuration to ensure the platform runs smoothly and meets your organization's data needs. We'll cover how to enable Microsoft Fabric within your tenant, the different types of licenses and how to assign them, how to set up workspaces and permissions, configuring and using core services in Fabric, and best practices for getting started with Microsoft Fabric. To get started with Microsoft Fabric, you need to enable it in your tenant. Here's how you can do that. The first step is that a Fabric admin needs to enable the platform in the organization's environment. The Fabric admin role can be assigned to a person with administrative privileges, just a Power BI admin, Power Platform admin, or Microsoft 365 admin. The admin must configure the necessary security and permissions at the tenant level to ensure that only authorized users can access and use Microsoft Fabric. Fabric's integration with existing Microsoft services means that this step may also involve ensuring connectivity between Azure, Power BI, and Microsoft 365 and other Microsoft services. Fabric is typically licensed via a premium per capacity model, which is suitable for enterprises that require more advanced features like large scale data processing and advanced analytics. In Microsoft Fabric, there are different licensing models, including Fabric Azure, Power BI, and Data Factory licenses. The administrator needs to determine which license model to use based on the organization's data and analytics needs. Once Microsoft Fabric is enabled, the next step is to handle licensing and workplace assignments. This involves making sure that the users have the correct permissions to access the platform and that they can utilize the right features based on their roles. Depending on the needs of your organization, users will be assigned different licenses. If your organization needs advanced features such as large scale data processing or real time analytics, users may require premium licenses. Fabric licensing comes in different tiers, including options for small scale, medium scale, or large scale operations, depending on how much data needs to be processed. Workspaces in Microsoft Fabric are central to collaboration. A workspace is essentially a container for data assets such as datasets, reports, pipelines, and machine learning models. Once users have the right licenses, administrators will assign them to specific workspaces. This ensures that the right people have access to the appropriate datasets and analytics tools. Workspaces are the central hub for collaboration and data management in Microsoft Fabric. Each workspace contains the resources and tools necessary for a specific team or project. Here's how to set up workspaces. A Fabric admin can create a workspace within the platform by selecting a workspace type, either an engineering workspace, a data science workspace, or business intelligence workspace. Each workspace will contain datasets, pipelines, models, and other resources that teams can use for data processing, analysis, and reporting. Assigning permissions. Permissions are an essential part of workspace setup. You need to control who has access to the workspace and its contents. There are various levels of permissions, including admin, member, and viewer permissions. Workspaces in Microsoft Fabric allow admins to assign roles based on the function of the user. For example, data engineers might have member access to the data engineering workspace, while Power BI users might have viewer access to the BI workspace. After enabling Fabric, setting up workspaces, and assigning roles, the next step is to configure and use the core services within the platform. Microsoft Fabric offers several key services that support data management, transformation, and analytics. Data Factory is the key tool for data integration in Fabric. Data engineering is used for processing large data sets and performing complex transformations. Lakehouses provide storage for raw data and processed data, and the connection between data engineering and lakehouses ensures that the data is ready for analysis or reporting. Once data is prepared and stored in lakehouses or data warehouses, it's time to use Power BI for data visualization. For businesses that need to process data in real time intelligence is configured to process and analyze live data. This could be important for industries like e commerce, finance, or healthcare, where immediate insights are crucial. To ensure a smooth adoption of Microsoft Fabric, here are some best practices for getting started. Start with a pilot project. Train your teams. Define your data governance and access control early. Optimize for scalability and monitor and iterate. Starting small with a pilot project, training users, and setting up proper governance and scalability are essential for successful adoption. In summary, enabling and using Microsoft Fabric involves several steps. Enabling Fabric within your organization by assigning the appropriate roles and licenses, setting up workspaces and configuring permissions to allow collaboration, configuring core services like Data Factory, Data Engineering, and Power BI to start using the platform, and following best practices for monitoring, training, and scaling your implementation. By following these steps, you can effectively enable Microsoft Fabric in your organization and empower your teams to start managing and analyzing data with ease. Now, let's get started with lakehouses in Microsoft Fabric. Lakehouses are a powerful architecture that combines the flexibility of a data lake with the performance of a data warehouse. They allow organizations to store both structured and unstructured data in one unified environment, making it easier to handle large data sets and run fast analytics. With lakehouses, you can use schema on read for raw data and still query data using SQL for structured analytics, similar to a traditional data warehouse. This gives you the flexibility of a data lake while also enabling fast query performance. Now let's walk through how you can create and use lakehouses within Microsoft Fabric. Let's get started with creating lakehouses in Microsoft Fabric. Log into Microsoft Fabric and navigate to the workspace where you want to create your lakehouse. The workspace is where all your data, assets, resources, and tools are managed. Inside the workspace, find and click the Create button, usually located in the top right or left corner of the workspace dashboard. From the list of resources you can create, choose Lakehouse. This option will allow you to create a new Lakehouse instance that can hold all your raw and processed data. Once you click Lakehouse, the system will prompt you to provide a name for the new Lakehouse. Choose a meaningful name that reflects the type of data you plan to store. For example, Customer Data Lakehouse or Sales Analytics Lakehouse. By default, one lake is the storage location for your lakehouse, a centralized data lake that supports Microsoft Fabric. You can also choose another location within your organization depending on the specific needs of your data architecture. After defining the name and storage location, you'll need to set up permissions, and you can assign roles such as admin, member, and viewer depending on the access you need to provide. This ensures proper access control and collaboration with your team members who will work with the data inside the lakehouse. The first task after creating your lakehouse is to explore the data. The goal is to understand the structure and content of the data that has been loaded into your lakehouse so you can prepare it for analysis. In Microsoft Fabric, there are several ways to explore data stored in your lakehouse. Using SQL, you can run SQL queries directly against your lakehouse. This is particularly useful if you're familiar with SQL and want to retrieve specific insights, filter data, or explore relationships between different data sets. For example, you can run simple select queries to see how the data is structured, use join statements to link tables, or group by to aggregate for deeper insights. Notebooks. If you need more flexibility, notebooks are an excellent way to explore your data in more depth. In Microsoft Fabric, you can use Python, Scala, or Spark SQL within notebooks to perform advanced data exploration. This allows for complex transformations, data profiling, or even statistical analysis. If you don't want to dive into code, Fabric offers a simple data preview tool where you can quickly see the contents of your lakehouse tables. This tool makes it easy to view your data and get a sense of its structure without writing any queries. A lakehouse is designed to handle both structured and unstructured data in a scalable and flexible way. Unlike a traditional data warehouse, which stores highly structured data in relational tables, a lakehouse can hold everything from logs and JSON files to CSVs and relational data. When we load data into a lakehouse, we are typically bringing in raw or semi-structured data and preparing it for transformation and analysis. This could be data from different sources, such as databases, APIs, cloud storage, and external applications or third-party systems. The beauty of the lakehouse is that it allows us to store these diverse data types together in a unified platform while keeping them accessible for future processing and analytics. Data flows provide a no-code, visually driven interface for loading and transforming data. This is ideal for users who don't want to write code but still need to automate data ingestion processes. S- For example, you have data stored in an SQL database and want to load it into the lakehouse for further analysis without writing any code. Using data flows, you can create transformations and directly map your source data to the lakehouse storage. You can create pipelines in Microsoft Fabric, which are designed for more complex data workflows. They allow you to schedule and automate data extraction, transformation, and loading tasks. For example, you have multiple data sources, such as external databases and CSV files, and need to regularly update your lakehouse. Pipelines help automate this process, ensuring that your lakehouse is always up to date. Shortcuts allow you to connect your lakehouse to external data sources without physically duplicating the data. Instead of ingesting the data into the lakehouse, a shortcut gives your lakehouse a pointer to where the data resides. This approach is useful when you have large data sets that don't need to be copied into the lakehouse, but you still want to query or reference them from within the lakehouse environment. For example, you have data stored in another platform like Azure Data Lake or AWS S3 that you want to access from your Fabric Lakehouse. Rather than copying the data into your lakehouse, you create a shortcut that links to the original location, enabling you to query the data directly. After successfully loading data into a lakehouse, the next step is to explore, transform, and visualize it. These are the key tasks to unlock the full potential of the data we've ingested. After exploring the data, the next step is transforming it to prepare it for deeper analysis or reporting. Microsoft Fabric provides a variety of tools to transform data. If you need full control over the transformation process, notebooks offer an excellent option. You can use Python, Scala, or Spark SQL to apply customer transformations to your data. For example, you can filter out rows with missing values, create new calculated columns, or even aggregate data into summary statistics. Data flows into allow you to apply ETL operations to your lakehouse data. You can visually design data transformations such as cleaning, aggregating, and reshaping data. You can apply filtering to remove irrelevant data, create aggregated columns for reporting, and even join different data sets together to create a more complete picture. Pipelines are designed for more complex workflows that involve multiple transformation steps. Once your transformations are designed, in data flows or notebooks, you can integrate them into a pipeline to automate the process and schedule it for regular execution. Pipelines are perfect for handling ongoing data transformations, such as nightly updates or real-time data streaming. If your transformation require external data, shortcuts provide a way to link to external sources without duplicating the data in your lakehouse. This is ideal for when the data is frequently updated and doesn't need to be stored within the lakehouse but should still be part of your transformation process. Power BI allows you to connect directly to your lakehouse and import the transformed data. You can select the data sources within your lakehouse that you want to visualize, making it easy to create reports and dashboards that reflect the most up to date information. The best practices for effective data handling in a lakehouse is to leverage notebooks and data flows Gen2 for flexible and scalable data transformations. Use Power BI to create meaningful interactive visualizations that drive insights. Automate and schedule regular transformations using pipelines to keep your data up to date. With these tools at your disposal, you're ready to extract valuable insights from your lakehouse data. Now that we've created a lakehouse, in this demo, we are going to explore three different methods for ingesting data into Microsoft Fabric. These methods include using Spark notebooks for advanced users who prefer code, using data flows For no-code visual transformations, using pipelines for automated and scheduled ingestion. We'll demonstrate how to take a dataset stored in Azure Blob Storage, transform it, and then load it into a lakehouse within Microsoft Fabric. By the end of this demo, you'll understand how to efficiently work with different ingestion methods depending on your needs. We will be working with a sample dataset stored in Azure Blob Storage. This dataset, called Shopping Trends CSV, contains customer shopping behavior data such as purchase categories, frequency of shopping, and customer demographics. Here are the steps we will follow for each method. We will connect to Azure Blob Storage. We will read the dataset. We will transform the dataset if necessary and load the data into the lakehouse. Let's get started by first setting up the environment and preparing to ingest this data into Microsoft Fabric. We'll start by using a Spark notebook in Microsoft Fabric, which is an excellent choice when we need flexibility and control over our data transformation and ingestion process. In your workspace, go to Notebooks and click Create Notebook. Select Python as the language for the notebook. Next, we need to configure Spark to connect to Azure Blob Storage. This involves setting up the storage account key to authenticate the connection. Here's the code we need to set up Azure Blob Storage connection. Now that the connection is set up, we can read the shopping trends CSV file from Azure Blob Storage using the code provided. Now that the connection is set up, we can read the shopping trends CSV file from Azure Blob Storage. Now that we've loaded the data, let's write it to a lakehouse in Delta format. Finally, let's verify that the data has been correctly written to the lakehouse. We can see that the shopping trends CSV file through the notebook code has been uploaded to the demo lakehouse in our workspace. To summarize, we set up the connection to Azure Blob Storage. We read data from a CSV file into a Spark data frame. We transformed the data and wrote it into a lakehouse in Delta format. Finally, we verified the data was correctly ingested. This process is just one example of how you can ingest data into Microsoft Fabric using notebooks. The power of notebooks is that you can customize your data pipeline with Python code to suit any of your data processing needs. Now let's dive into the world of data flows, which are powerful no-code visual tools for transforming and ingesting data. Let's take a quick look at what data flows are and why they're so valuable. Data flows allow you to ingest, clean, transform, and load data from various sources. Example, Azure Blob Storage, SQL databases, Excel files, etc. into destinations like lakehouses or data warehouses. The best part is that you don't need to write any code. Everything is done visually with drag and drop features for data transformations. We'll cover the key concepts behind data flows and how they fit into the Microsoft Fabric ecosystem practically. To access data flow in Microsoft Fabric, log into Microsoft Fabric using your credentials. From the left navigation pane, select Data Flows. Under the Transform section, this is where all your data flows will be listed. To create a new data flow, once you're on the Data Flows page, click on Create button to start creating a new data flow. In the Data Flow Designer, click on Add Source to define where your data is coming from. You'll see a list of available sources such as Azure Blob Storage, SQL Server, Power BI, Excel files, etc. Select the appropriate source. For example, if you're ingesting data from Azure Blob Storage, choose Azure Blob Storage from the source options. Configure the connection by providing the storage account name, container, and file name, example, shopping trend CSV file. After adding the data source, you can now apply various transformations to clean and modify the data. Click on the Transform pane to open the list of available transformations. Common transformations include removing columns, eliminating unnecessary columns, filtering rows to apply conditions to filter data, rename columns to make more meaningful or standardized names, group data by certain columns and perform aggregation operations such as summing up values or calculating averages. Drag the desired transformation from the pane and drop it on the canvas. Configure the transformation based on your needs. After successfully running the data flow, you can schedule it to run periodically to automate the process. To do this, go to the Schedule section and define the frequency of the data flow execution. This feature is particularly useful for automating data refreshes in your pipeline. In conclusion, data flows in Microsoft Fabric offer an intuitive, visual approach to data ingestion and transformation. They are ideal for users who want to avoid writing code but still need to perform complex data transformation tasks. By following the above steps, you can set up a data flow that automates the ingestion and transformation of your data, saving time and reducing the risk of manual errors. Data flows allow you to ingest data from various sources like Azure Blob Storage, SQL, and Excel. You can apply transformations to clean and modify the data, including removing columns, filtering rows, renaming, and aggregating. Once set up, data flows can be scheduled to run periodically, automating your data pipeline. Now let's discuss pipelines. Pipelines are used to orchestrate data workflows, providing a way to automate and manage the execution of multiple data flows, notebooks, and other tasks within Microsoft Fabric. Data flows are focused on transformation tasks. Pipelines can help you to create an end-to-end workflow that includes various tasks in a specific order. Pipelines provide the ability to chain multiple tasks together, creating a sequence of steps that will execute in a defined order. You can schedule a pipeline to run at specific times or trigger it manually when needed. Pipelines consist of different types of tasks that can execute other tasks like data flows, notebooks, SQL scripts, and even custom scripts. Tasks in a pipeline can have dependencies, ensuring that certain tasks run before others. For example, you might want a data transformation to run before data is loaded into a lakehouse. Now let's look at a step-by-step guide to creating a new pipeline in Microsoft Fabric. Log into your Microsoft Fabric account. On the left navigation panel, click on Pipelines under the Data Integration section. This will open the Pipelines workspace where all your pipelines are listed. You can also click on New Item to create a pipeline. After clicking Create Pipeline, you'll be taken to the Pipeline Designer interface. This is where you'll visually design your pipeline. To configure the pipeline, you can add a description to describe what this pipeline does. You can configure any parameters that might be needed for your tasks, if applicable. Now that we're on the pipeline designer, we need to copy data from the Azure Blob Storage to the Microsoft Fabric Lakehouse. In the Pipeline Designer workspace, click on Add Source. This allows you to ingest data stored in Azure Blob Storage. This will open a list of selected source options. Once you've connected to Azure Blob Storage, You've successfully created a pipeline that applies transformations where needed and loads the data into a lakehouse. You also learned how to schedule the pipeline for automated execution and how to monitor its progress. You can explore adding more advanced tasks such as executing SQL queries, running notebooks, or handling more complex data transformations and aggregations. Welcome to the final segment of today's session. In this last section, we're going to take a step back and wrap up everything we've learned during the Microsoft Fabric demo. I'll walk you through some key takeaways from the demo and tie everything together, focusing on how the concepts we discussed are used in real world scenarios. We started by diving into end to end analytics in Microsoft Fabric, where we saw how Fabric integrates various tools like data engineering, data science, Power BI, and real time intelligence. Microsoft Fabric isn't just a data storage solution, it's a complete unified platform for all your data processing and analytics needs. Let's review the main areas that Fabric covers. Data engineering. Powered by Spark, it helps with large scale data transformations. Data science provides tools for machine learning and scalable model training. Power BI enables business intelligence and visualization of data. Real time intelligence allows for querying and analyzing data in real time. The combination of these features helps data teams from data engineers to business analysts to collaborate efficiently, making Microsoft Fabric a comprehensive solution for all types of data workloads. In Microsoft Fabric, roles like data stewards, data engineers, and Power BI users all have specific responsibilities. Let's quickly review these roles. Data stewards manage data governance and quality across the environment. Power BI users create reports and dashboards to drive business decisions. Data engineers use Spark and data pipelines to move and transform data. Each role has a vital part to play in managing and utilizing the data within Microsoft Fabric, and understanding this collaboration is key for teams working with large scale data. As we've seen today, Microsoft Fabric is not just about storing and processing data, it's about leveraging data to create business value. When organizations ingest and manage their data using lakehouses, they unlock the potential for powerful insights. As we conclude, let's visit the key takeaways from today's demonstrations. Microsoft Fabric is a unified platform. Fabric provides an integrated environment for all aspects of data management, from ingestion to reporting. Lakehouse provide flexibility and power. There's multiple ingestion methods. Whether you're using notebooks, data flows, or pipelines, Microsoft Fabric provides multiple ways to ingest data into a lakehouse, each suited for different needs. Notebooks are ideal for more technical users. Data flows are best for those looking for a no-code interface, and pipelines are useful for automating recurring tasks. Delta format allows for ACID transactions and efficient querying. It helps with maintaining the reliability of large datasets and supports scalable analytics workloads. Power BI integration. By connecting Power BI to your lakehouse, you can visualize and report on your data, turning raw numbers into meaningful business insights. This is one of the easiest ways to enable decision making based on data. We've touched on a lot of great concepts today, but the world of data is rapidly evolving. Here are some exciting developments that we can expect from Microsoft Fabric and lakehouses in the near future. Increased AI and machine learning integration, enhanced real time data processing, improved data governance, and expanded integration with third party tools. I encourage you all to continue your exploration of Microsoft Fabric and lakehouses. Whether you're interested in learning more about data engineering, data science, or real time analytics, there are plenty of resources to help you grow your skills. I hope this session has helped you understand the power and potential of Microsoft Fabric for data ingestion, transformation, and analytics. Whether you are a data engineer, data scientist, or business analyst, Microsoft Fabric provides a unified, scalable environment to support all your data needs. Thank you for joining the session.